Hello all, in this video we'll be focusing on the derivation of equations of motion. Before deriving the equations of motion, let's take a brief account of what the equations of motion are. Galileo Galilei formulated three equations of motion of uniform accelerated motion. These three equations are v is equal to u plus at, final velocity is equal to initial velocity plus acceleration into time. S is equal to ut plus half of at squared. Displacement is equal to initial velocity into time plus half of acceleration into time squared. In equations of motion, S stands for displacement, it's not distance, it is also not speed. Velocity is nothing but speed with a given direction. Acceleration is rate of change of velocity. The final equation is v squared minus u squared is equal to 2as. Final velocity squared minus initial velocity squared is equal to 2 into acceleration into displacement. Now, let's start deriving the equations of motion. First one is v is equal to u plus at. We all know that acceleration is equal to v minus u divided by time, because it's the rate of change of velocity. Change of velocity is equal to v minus u, and rate of change of velocity is equal to v minus u divided by time. Whenever in physics the word rate comes, it means we need to divide by time. For example, rate of work is power. Work by time is equal to power, like that. So from this, when we rearrange, we get v is equal to u plus at. So a into t is equal to v minus u. We bring the time and we multiply it to acceleration, and then finally v is equal to u plus a plus at. We bring u to the left hand side and then we rearrange it. This is how the first equation of motion is derived. Second equation of motion is a bit complicated, but when we learn it becomes easy. It is S is equal to ut plus half of at squared. S is equal to ut plus half of at squared. Now, average average velocity into time is equal to displacement. This is how speed works. Speed into time is equal to distance, and velocity into time is equal to displacement. Average velocity into time is also is equal to displacement. Since average velocity into time is displacement, average velocity is nothing but v plus v plus u divided by 2, because whenever the word average comes, the number of quantities will be divided by the sum of the quantity. As average velocity is equal to v plus u by 2, displacement is also is equal to v v plus u by 2 into time, right? Average velocity into time is displacement. Average velocity is v plus u by 2, so displacement is v plus u by 2 into time. Now, from the first equation of motion, we have v is equal to u plus at. Since v is equal to u plus at, whenever we have a quantity of final velocity, we can replace it with initial velocity plus acceleration into time. Therefore, s is equal to u plus at plus u. U plus at is equal to v, and we have v over here. Since v plus u by 2 is average velocity, u plus at plus u plus at is v. So we replace v with u plus at, and we have u over here. So we have u over here also by 2 into time. S is equal to u plus at plus u by 2 into time. Therefore, S is equal to 2u plus at divided by, sorry, 2u plus at divided by 2 into time. Therefore, S is equal to 2ut plus at squared, we need to put brackets, whole divided by 2. Now we are multiplying 2 with 2u and 8a because the plus symbol divides these two variables. We multiply t with both of these. So we get 2ut plus 8 squared by t. Finally, S is equal to ut plus half of a t squared. Since we have a 2 over here, we can cut these two because 2 into 1 by 2 is 1, and 1 into whatever is equal to that whatever number. So v is s is equal to ut plus half of at squared. Since we have divided by 2, we have this plus separating these two numbers. We divide at squared also by 2, so it's half of at squared. This is how the second equation of motion is derived. Here comes the third equation of motion, which is really easy to derive. V squared minus u squared is equal to 2as. V squared minus u squared is equal to 2as. We need to bring out a similar perspective of how we derive second equation of motion. So now we start with S. We start with displacement. Displacement is equal to average velocity into time. Displacement is equal to average velocity into time. As noted above, average velocity is nothing but v plus u with brackets, v plus u divided by 2 into time. Now here is when the new concept comes. From first equation of motion, we have v is equal to u plus at. Since v is equal to u plus at is equal to v minus u. T is equal to v minus u, v minus u divided by a. T is equal to v minus u by a. Therefore, S is equal to v plus u by 2 into v minus u by a. Now we have two things in the denominator. So since these two are in multiplication, we can just multiply it as S is equal to v plus u into v minus u divided by 2a. So when we bring this 2a to the left hand side as s, it becomes a product. Therefore, 2as is equal to v plus u into v minus u, brackets again, v plus u into v minus u. In math, we learned that a squared minus b squared is equal to a is equal to a plus b into a minus b. into a minus b. We use a similar concept here. Instead of a and b, we have v and u. Therefore, v plus u into v minus u is equal to v squared minus u squared. And hence, we have derived the third equation of motion. V squared minus u squared is equal to 2as. We bring 2as to the right hand side and these two to the left hand side, and hence we have derived three equations of motion. So, hope the concept is clear. You can pause the video and you can watch this video how much ever you want for better understanding. Thank you so much for watching this video.